Okay, so once again, good afternoon, and thanks for taking time to join us today. There are a team of presenters, including myself, Amanda Eberly, Gio Rapicciolo, Robert Gundy, Diana Soteropoulos, Janelle Johnson, and Tara Cornelise will be here to share some background and do some demos and discuss RARECAT with you all. RARECAT is the Rapid Assessment of Rarity and Endangerment Conservation Assessment Tool, also known as RARECAT. Just one more thing. If you have any questions during the presentation, feel free to add them to the chat. And any questions that you'd like to ask, like turning off your mic to do so, just save those to the end, please. Okay, so this tool would not exist without funding from multiple sources, including the Bureau of Land Management, Band Foundation, Environment and Climate Change Canada, and NatureServe Canada, and the United States Botanic Garden. We're really grateful for their support to see this project through. And I've been the project manager on this for a couple of years and have been working with Gio, the sole developer of the tool, since its creation in 2023. We have a large group of folks who are integral in the planning of new functionality and testing that functionality and the tool throughout multiple rounds of adding new functionality. And they are listed here. So the reasons this tool came to be are also the guiding principles for its development. It was developed out of necessity and in part response to the increasing volume of observation data that's very critical for ranking work. And it's desirable to integrate this data into our workflow with standardization, efficiency, quality, simplicity, and flexibility in mind. And to the last point of flexibility, this tool is intended to rank a variety of organisms that are rare or common and at the subnational, national, or global level. Just a few highlights. It's built in R and it has a Shiny app user interface. Its primary goals are to collate spatial data records, specifically points. It cleans up observation data automatically and manually, calculates 3 rarity metrics derived from spatial calculations that represent 3 rank factors in the ranking process. It summarizes and provides temporal context to data and can inform trends. It can process many species or one at a time. And there are flexible options for the user to integrate the information into the ranking process. The initial prototype of this tool came to be in 2023, actually quite quickly during the great outage of GeoCat, which was a much-loved tool that we used previously and of significant influence in the development of RARECAT. In 2024, we committed time and resources to work through some of the problems identified in the prototype or just functionality that we wish exists. And that was version 1.1.1 was our foundational single species mode. And up until that point, NatureServe staff were the only users of the tool. In 2025, we added additional functionality, including the ability to process multiple species and a particular interest, releasing it to the network and adding this a much larger user base. So, and moving forward into the fall and winter, we're going to continue working on fixing bugs, but really the incorporation of new functionality is on hold for the time being. So before talking further about RARECAT functionality, I just want to set this in the stage of the ranking process. So the ranking process follows some general steps: research and data collection, application of information and data to rank factors, recording the supporting information, review, and publication of that information. And so just a little more information on each of those steps. The first step, we're compiling and vetting observation data, reviewing maps and literature, and contacting experts. The second step, we map those found observation data and calculate rarity metrics. The observation data combined with literature and other gathered information is used to assess rarity, threats, and trend factors outside of those rarity metrics. And we use our NatureServe guidelines on applying the information to the factors. We take the factor scores and apply those to the rank calculator, either in biotics or the Excel version, to get a global, national, or subnational rank. And as a reminder, we have 10 factors that we can consider during the ranking process. And after getting through those stages, there's typically some level of review, either content methodology focused or content focused on the species itself. And those revisions may result in going back to the beginning and doing additional research or reassessing factors before finalizing the assessment for publication. And for global assessments, that's NatureServe Explorer and our API outlets. But at the subnational level, that might be regional websites, and of course, maybe peer-reviewed papers or reports. And so looking at all these components together, we can look at where RARECAT intersects the process. So the functionality of RARECAT is directly informing several steps of the process and calculating rarity metrics for 3 specific factors: range, extent, area of occupancy, and number of occurrences. RARECAT can assist with the input of factors into the rank calculator or biotics, but it's not a fully automated process. And temporal summaries of data can inform, along with other considerations, long and short-term trend. So with this background on the methodology side, Gio is going to step in and share a bit about the structure and methods of the app.
Thanks, Amanda. It's great to be able to chat with you all again. So I was just going to give basically everybody a quick overview of the technical underpinnings of RARECAT and how we put it together. And please free to contact me for more details, because clearly we don't have a lot of time here. But RARECAT basically has 3 main bodies of code. It's constituted of 3 main chunks of code. This is all open source code, which will be made available throughout the network should you want to have a look and reproduce the code. The 3 chunks are the taxonomy part, which gets hold of taxonomic definitions from GBIF and from the NatureServe taxonomic backbone. There's a distribution part, which really has to do with extracting, cleaning, vetting distribution records, point records, as we said. And a lot of data comes from the GBIF API or can be uploaded by the user from a variety of platforms that we've grown accustomed to. And so there's functionality to clean, integrate all those data together, map them, and so on. And then the third body of code really has to do with the calculation of the rarity metrics. And this code leverages existing code bases, like the R package, CRAN, that's available on CRAN, RED, which is really officially for IUCN red listing exercises. There's a tool out of Kew Gardens for also for red listing, the rapid least concern. And then there's a lot of custom R code, specifically, for example, for the calculation of number of occurrences, which is really a NatureServe specific ranking challenge, as well as a lot of custom code, obviously, to wrap this all up and connect with NatureServe specific processes. Next slide, please, Amanda. So I made this perhaps slightly tenuous link with an electric vehicle to convey what the structure of RARECAT is. And essentially, RARECAT is connected to GBIF and NatureServe Explorer, which provide the electricity, if you will, or the data. And the data are extracted via, as I mentioned, R packages that talk to the APIs, the GBIF API and the NatureServe Explorer API. So we get data into the vehicle, and the body of the vehicle is shiny, as we talked about. So the framework that the app is built in, really, the user interface is shiny. You will find a dashboard, and so the map-based interface is built in Leaflet. And the engine of this application is all the code that we talked about, which it essentially supports with the calculation of rarity metrics, as well as puts records in temporal context. And so you'll find a lot of visualizations and custom R code. One thing I wanted to note here, and why this analogy may be helpful, is that there is no storage of data inside the application. So you won't actually see batteries inside this car. There's no long-term storage of data. That means anything that is uploaded by the user or downloaded inside the application will leave the application and be deleted the moment that you disconnect from the application. So when you close your browser window, anything you may have uploaded on there gets removed and only exists as a temporary file. Next slide, please, Amanda. So I just wanted to give you an overview of where some of these tools enter the application. We'll have an in-depth look at the interface in a minute. But essentially, users are prompted to enter a binomial or a taxonomic name. And this is where you'll get options of taxonomic concepts that come from either the NatureServe taxonomic backbone via NatureServe Explorer or the GBIF taxonomic backbone via RGBIF. And so you'll be able to choose a taxonomic concept that relates to the taxon you want to be ranking. Next slide, please. For the distribution part, you will see that, as we mentioned, a lot of the bulk of the data that is downloaded by default comes via GBIF. Any other data sources need to be added by the user and can be uploaded from a CSV file. And the GBIF extraction can be really quite detailed. As you'll see, there's an option to go into a lot of detail with the different data providers to see if you want to be adding those or excluding those. For example, if you do not want to be using eBird data to rank a bird, there's a ton of eBird data. Perhaps you don't want to deal with that. You can exclude that ahead of time and move forward with a more streamlined rank. I'll just answer really quickly questions that are coming through the chat. You can rank sub-taxa or infraspecies. Those will be available to you. And you can combine various infraspecies at the level of a full species and choose which ones to include based on their definitions. Perhaps let's hold follow-up questions on that till the end, but infraspecies are accounted for. Next slide, please, Amanda. The last bit, as we talked about, is the rarity metrics calculation. And this is where the various existing tools support the code base of RARECAT, as well as a lot of custom R code. So you'll find in the applications ways to calculate the range extent, area of occupancy, and the number of occurrences. And those can be added or removed from the analysis and downloaded as part of a RAN calculator download to be integrated within your assessment. So I'll just leave it at that as a quick overview. But again, please feel free to get in touch with any more specific questions, and we'll be sharing code as well as all the documentation that's available for everybody to find out more about the methods. Thanks so much.
Thanks, Gio. So from here, we're going to move into a few demos and discussions of how to use RARECAT. To start, as I mentioned, this is version 2.1.1, which can be accessed from the URL at the top of the screen. And within RARECAT, there's a few things that can help get you started. We have a couple tutorials that have been added in the tutorial section. There's documentation, which is fairly in-depth on how the functionality works in the tool. And newly added is a crowdsourced forum where you can ask questions and answer questions, and also find links to templates and other resources. And this was newly added, so we're just building that out, but feel free to use it. And yeah. And also, some of the fields have a little information hover for help symbol. And for those, there's some expanded tips and definitions of how to use those fields. So the first demo that we're going to do is a very simple demo of how to use single species mode. So the first step in single species mode is to select the type of assessment, the assessment area, and the taxon. In this example, a national assessment is selected for Canada. So first select the assessment type, Canada is the location, and then a species is entered, Claytonia virginica, a spring ephemeral plant, and you'll see that a variety of options are listed after searching for that species. So the first set are responses based on your entry from the NatureServe Explorer API for the names that we have in essentially in biotics. And then following that are options from GBIF. The advantage of selecting a NatureServe name is that you're going to, when that name is searched against the GBIF data and taxonomic backbone, it will use both our accepted name, but also our synonyms to pull data. And if you select data at the species level, it will also pull in associated and for specific taxa for that species. And so in this case, I'm selecting the full species record from NatureServe. And then I get to the next prompt. Oops. Okay. And so in this window, you'll see there are two options. You can start your assessment with all records up to 5,000, or you can select specific data sets, which allows you some ability to filter up front. In the select specific data sets option, you can see that there are two groups of data sets: occurrences, which is largely specimen data, and human observations, which includes a variety of sources, including community science data. And so you could just upfront, if you have a ton of data, say for this species, Maybe it is a lichen that can't be identified through images. Say, I don't want any human observations and exclude all of those data at the onset. But there might be other, you can also hone in on just specific data sets that you want to remove, that you don't have enough information about, and the reliability of the identifications. You may have also set up a file from a particular source that you vetted or had access to obscured coordinates. So you just want to say bypass iNaturalist because you have access to particular records through another means. And so there's a few reasons where you might take this path, but it gives you flexibility to review each of the data sets coming in and determine if you want to keep them or remove them. For this example, we're going to start the assessment with 5,000 records. And I'm using the toggle to officially add those records from GBIF. At this point, you could also browse and add one or more CSVs of user-created data sets to import and combine with the GBIF data. So now that our data are loaded, we'll look at some of the map view features that are helpful for navigation and data review. So starting at the top, you can zoom in or zoom out. You can reset view. You can search for and zoom to a location. There are a variety of base layers that you can choose from. There are tools for adding points and also for selecting points. When you click on a point, the details of that record are displayed below the map. This table has a scroll bar associated with it. If you scroll the whole way to the right, the final field, which is a URL, links you back to the GBIF record. You can select multiple records in that table, and you can delete records from the table. For some sources in particular, once you get to GBIF, you can then drill down to the original record and make some determination on whether that is a record that you want to keep in your analysis. And if it is one that you don't want to keep, you can use the toggle to remove that selected record from your data set. You can also add points using the draw marker tool. And you can either search for a location, which will zoom right to it, or you can use the zoom in tool to get to that place. And once you've found a particular place where you believe the species exists, and you can add a point if one doesn't exist already. And once you have refined what you want to include based on geography or maybe exclude, there are numerous filters that can also assist with data cleanup. You can learn more about each of these in the documentation link, but the filters are largely found in the lower left-hand corner of the screen. They include removing centroids from your data set. You can set the time frame of records that you want to include. You can set spatial uncertainty for the records to include. You can hone in on a subnation or nation by using a filter. You can review the taxonomic concepts included. So in some cases, GBIF taxonomy and NatureServe taxonomy might not be at the same place. And the names that are presented in this table are the names that are associated with the records, independent of the GBIF backbone. And so you can review what's included and decide if that's part of the concept that you're assessing. The top data sources included are listed, and you can remove those if needed. If you didn't do it at the beginning, you can select record types by group. You could remove all human observations, by clicking on that word and hitting backspace, or vice versa, preserve specimens if needed. And then a new filter that we've added is selecting element occurrences by rank. So if you import a element occurrence data and they have EO ranks, you could exclude certain ones, say occurrences that are extirpated from your data set. So for the Claytonia, the centroids are removed from this data set. The time frame is set to include only data from the last 40 years. And in this case, no other filters are added or used. One thing to note is that there is the ability to download records. And if you want that full data set, the original set, you would need to download that before filtering. And the next step is to calculate the factors. And you just simply toggle on the switches and those factors will be calculated. Range, extent, and area of occupancy are pretty snappy, but when you have a lot of data, a number of occurrences can take some time to calculate. You'll also see that you can adjust the separation distance for occurrences to a value that's appropriate for the organism you're assessing, and grid cell size can also be changed to 1 kilometer by 1 kilometer. So here are the results for the Claytonia for Canada based on GBIF data, no more than 40 years old, and with centroids removed. So you're presented with both the factor score and the estimate, which correspond to fields and biotics, and the factor score, of course, corresponds to the field in the Excel rank calculator as well. And from here, you can download your records. So that's just the filtered data, or you can download the rank data, which has several tabs included in it. I'll jump to that in a moment. So this is just a quick view of the data file download. There's a limited number of fields that are exported from GBIF. And it's not their full collection of attributes, but there's quite a few of them that are included. And the rank calculator download provides you with a row that can be copied and pasted into the Excel version of the rank calculator. The analysis summary tab provides that same information plus the estimates and all of the parameters that you set and a summary of the data included. And so we're going to back up just for a moment and look at one of the filters that were available that I didn't talk about. And our vertebrate zoologist, Robert Gundy, is going to describe that filter to us.
The month filter is most applicable to migratory birds, although I could see some usefulness to anything that migrates, such as maybe anadromous fishes or bats. If you go ahead and press play, Amanda. So down the lower left, you'll see my cursor there for selecting time of year. You'll click on a box and then delete the months that you don't want included. So everything's already included, and you'll see that there's a cursor there. So you don't actually have to select each month that's coming chronologically if you have several in a row. It will take a couple of minutes for this to run, and you'll see it go through phases, which I left here for you to see that you have to wait till it's fully ready, and it will. And then if you want to add months back in, you can just click back into that box, and then there will be a drop-down menu to show you the months that you can select back in. That's it.
Thank you. Okay, opposite. One other thing that we didn't discuss is a section opposite of the filters in the lower right-hand corner of the single species mode. There are two options for temporal summaries of data. To learn more about the temporal analysis, you can check out the documentation, but also be on the lookout for a video tutorial that we'll add on how to use that tool. Diana Soteropoulos, a botanist at NatureServe, is going to demonstrate the change over time calculations.
In the process of filtering historic and extirpated observations, changes in rarity factors may indicate that trends should be examined. In the bottom right corner of the RARECAT interface, the time periods for analyzing suggested trends can be entered to calculate the rarity change by time period. Here, all data, 1800 to 2025, is entered for time period 1, and non-historic data, which is often a 30-year cutoff for many perennial vascular plants of 1994 to 2025, is entered for time period 2. There are 4 metrics available to view. The change in number of records to see available data may be more informative through the temporal analysis tool with that video that's coming out. But within this, I like to look at range extent, area of occupancy, and the number of occurrences. And we can see that range extent has had the greatest change over time with the loss of populations in the eastern portion of the range, while AOO and the number of occurrences ranges have had a 40 to 49% loss. From here, you can verify this information with known information on decline, threats, and known extirpations in combination with this calculation to estimate trends.
Thank you, Diana. Okay, so now we're going to take a look at multi-species mode. This is in a separate tab within RARECAT. The workflow for multi-species mode is a bit different as the filters and parameters are selected up front. And to learn the behavior of multi-species mode, we would recommend starting with just a few species and also review the documentation. Also different is how you enter the taxa. There's not as much review and choice in the process, but what you will do is either paste a list into the text block, or a list is developed from an observation file that the user can upload, and or from taxonomic or from names that are in a rank calculator file that can also be uploaded in multi-species mode. So I'm not sure if everyone is familiar with some of the queries that are built into the rank calculator, but there are within one tab called Export from Biotics 5 in the Excel version of the rank calculator, there are a few queries that will allow you to export existing ranking information from subnational, national, or global records for the rank calculator. That export will work in multi-species mode. And one thing that it can support is some of the comparison summaries in the results table that are based on previous values for range extent, area of occupancy, and number of occurrences. So I'm going to demonstrate a very simple rarity analysis for 2 species for the state of Florida. However, there are other approaches to this process and like how you start it up. So the first step is to select the assessment type. We're doing a subnational assessment, and then select the state, which is Florida. Next, I'm going to paste a species list. And I'm not selecting any filters in this case. There is an ability to do that later. And I'm going with the time periods that are set in the default settings for the temporal change rarity metrics. And so this can take, the more species you have, the longer it'll take to run. We'll just jump over to the results table. So after that runs, you're presented with a table with a summary of the factor scores for each species in the assessment. If you have uploaded a rank calculator for comparison, you'll see a comparison of the previous range extent with the new value, and same for area of occupancy and number of occurrences. And based on the parameters that we had didn't change, but we're in the first step, you see a calculation of percent change for range extent, area of occupancy, and number of occurrences based on all data as compared to data from the last 30 years. And so I can examine one or both of these species in more detail from this point. So you can take an assessment back to single species mode, where you can use all of the filters and available in that view. And once you have gone through the steps of adding, deleting, or refining what you want to include, you can send that species back to multi-species mode. Where the factors are, oops, sorry about that. Where the factors are then updated in the results table to reflect the data based on the refinements that you made. And when you copy an assessment back over after reviewing, one thing that happens is in the review column, you'll see that it's checked. So if you want to review each one, you can keep track of that as you go. And then you can download a rank calculator, the rank calculator data, which has a row for each of the species included, the rank factor values, and you could compile many of these analyses together and potentially run a batch update using instructions linked in the Excel version of the rank calculator to get the information back to Biotics. And then the assessment details are also provided in multi-species mode. Okay, so we're going to switch gears and have one of our botanists, Janelle Johnson, describe external data compilation for RARECAT and troubleshooting.
So there are several reasons why you might need to upload CSVs with additional data to calculate the rank factors. The most common reason is that data are missing from GBIF. The locations may be withheld or obscured, the data license may not be compatible, data quality may not meet standards, such as casual or needs ID iNaturalist observations. New records might not be uploaded to GBIF yet, or you have data that's from other sources like your local biotics data. The obscured iNaturalist locations are randomized within a 0.2 degree rectangle, which can inflate the spatial factors, especially for rare species. These can be removed in RARECAT with the spatial uncertainty filter. Herbaria and museums may withhold coordinates entirely, and GBIF does not import data with restrictive licensing, such as copyrighted data. iNaturalist is an important source for recent records, but only 40% of records are shared with GBIF due to quality and licensing issues. Next. When there are recent taxonomy changes, you may need to manually select records from older synonyms and combine them to get a comprehensive data set. Next. Sometimes when ranking an infrataxon, especially those that are difficult to identify, you might find many of the records that are only identified to the parent species. You may need to filter the parent species records by geography or other traits to find hidden records of the target infrataxon. In the example on the slide, purple squares contain records of the parent species, and other colors show geographically distinct infras. Next. When preparing CSVs for upload, you can use a RARECAT download as a template or find a template in the forum knowledge base. The 3 fields in red are the minimum required fields, and the other fields that are listed here are used for the data filters. RARECAT can import multiple CSVs with different column headers. You can also use external scripting tools to combine files from different sources. In the RARECAT forums and knowledge base, you can find an upload template with a data dictionary and instructions for exporting data from your local biotics. iNaturalist imports are handled slightly different during upload, and that will be the topic of a future forum post. So Geo is doing great work to improve RARECAT, and some of these issues may be fixed in future releases, but these are some of the current problems that we know about. The RARECAT pages time out fairly quickly, and Geo has tried to set the timeout longer, but it's ultimately controlled by the Shiny app and can be as short as 10 minutes. So if you've spent a lot of time cleaning up the imported data, save your work by downloading the records in case of a timeout or it crashes. If either of those happens, all of your records will be dropped. So if a CSV crashes immediately on loading, the first step is to open the file in an editor like Excel and check for the following issues. It may be missing some column headers. There may be no data, or you could have lots of rows, but none of the rows contain coordinates. Rows without coordinates will be skipped, but at least one row must have some coordinates. Multiple headers that contain the word latitude or longitude in the name. There can only be one latitude and one longitude. Again, iNaturalist downloads are handled a little different. The latitude and longitude must be in decimal degrees. Only positive and negative numbers are allowed. All other coordinate systems have to be converted, and you can check for non-numeric characters in Excel by sorting these columns and looking at the first and last records. Extra separator characters in text can sometimes cause cells to shift to the right, and this can push text into the latitude and longitude columns. If your CSV still crashes after fixing these issues, try deleting extra fields that are not used by RARECAT. Some of the pan-Pacific species are problematic when calculating the range extent and AOO because they cross the antimeridian. Many of these species that extend out of the Arctic regions will have a range extent larger than 2.5 million square kilometers anyway, so they will be in the largest category. And RARECAT uses external resources, so it is subject to external outages. So if you experience any problems, first check the forums, then post a new topic if you can't find an answer. As the forum grows, more answers will be available. You can also submit feature requests for future releases. If you find a bug or the forum can't answer your question, submit a help desk ticket in the forum or by email. Now back to Amanda to answer your questions.
Thank you, Janelle. That is everything that we have prepared for today. So we have at least 15 minutes left for questions. And I have not been monitoring the chat. Let me end this. But we can go ahead and allow for unmuting. Maybe if you want to raise your hand, and then we can unmute you if you would like to ask a question. This meeting is recorded. I do see that question came up.
Amanda, there's a question from Jamie about the use of sensitive species data. And I think I'm understanding that this is really talking about connection between RARECAT and biotics data directly, which I think, and correct me if I'm wrong, but we can rule out for now or in the short to medium term. But yeah, I don't know if you want to add more to it. Basically, the question is asking whether, you know, some user access restrictions could allow them to view biotics data directly within RARECAT as opposed to having to download it and then upload it as a CSV.
At the moment, that's not possible, but I think it's something that we'd have to talk about in the future with the biotics development team to see what the best way to support that interaction. One thing we do at the global level is we, on a regular basis, export using a script all of our species data and prepare CSV files for those so that they're ready to use in RARECAT.
Thank you. I actually happened to be working on something very similar to this for my state wildlife action plan, and I would, Gio, if you're willing to share code, I would love to see what you've got and also share with you what I've got, because we've just tried to really automate some of those data collection processes in a similar way that you've done here.
Yeah, absolutely. The code is already available, and I can share it. Currently it's in a repository that's managed by myself and at my organization, but we're going to transfer that to NatureServe and then share it with everybody. So perhaps we'll wait until NatureServe is in charge of the code to share it out to everybody. But it is available right now if that's an urgent request.
Is there anything anyone wishes we demoed, but we didn't? Any particular functionality? Okay. Just looking at this question from David.
Amanda, the way we can filter out those obscured iNaturalist records is using the spatial uncertainty filter, because those obscured records will have an obscured meter distance of more than 20,000.
Yeah.
So you can set the filter at 1,000 or 5,000 or 10,000, and it will remove those obscured records.
Does that answer the question, David?
Sorry.
Yeah, I'd love to see that demo. And better yet, I think somebody was asking about how do we get to the true source data location for a lot of these species. And I've seen this in a analysis before where an end user doesn't realize that the stuff from GBIF is rife with errors at times. And it does become problematic, for some of these more obscure salamanders and such.
Yeah, so you can use the filters that are available in the tool, the locational uncertainty filter, but when you download the data that were included in the analysis, that field is also included, so you can look at it more closely. And you have the URL links to go back to those source records. But GBIF, doing an automated using RARECAT to pull data from GBIF for a T&E species might not be the best path or recommended. So if you have access to the data in your local biotics or have permissions through other sources, you can put together files of the exact data that you want included in an assessment, as opposed to using GBIF, because it certainly is problematic. This has been used extensively for global ranking. It has been used at the state level, but I'm not sure if anyone on the call who's used it is available to speak to that. Lindsay, you have your hand up. Do you want to ask your question?
Yeah, I just wanted to ask about the option for removing GBIF coordinates that are based on centroids. Are those records that are like county level or watershed level, and so they just take the centroid of some large geography? Is that what that means?
Correct. It could be based on county. I know at least there are county centroids, but I believe there could be other types of centroids. And Gio, I don't know if you know that offhand.
Yeah, there's a number of basic checks that are done there, including if there's a note with the record that indicates that it is a centroid. There's also very specific uncertainty values that refer to some kinds of centroids, like city centroids or county centroids. And at times there's things that are known, like the coordinates of herbaria or collections and other things that are often removed as well. Yeah.
Thank you.
Jamie, do you have a question?
Yeah, with those occurrence records with that obscured location data, would you consider adding a checkbox or a drop-down menu or something similar where you could select to automatically filter out observations with like greater than 1,000 meters of coordinate uncertainty?
Yeah, so we have left this open to the user to set the level of locational uncertainty, because I think for some species that are very limited with data, sometimes even though, well, depends on the factor that you're calculating, what their utility could be. But for something like range extent, sometimes those can be useful for filling in gaps.
So that makes sense.
Yeah. That's what I would, I don't think we're considering adding just one obscured filter.
Okay, thank you.
Yeah. Michael, you have a question?
Not a question, but a comment. You'd asked about states using it. We have tried. The issue we've had mainly is it takes too long, even with just a few occurrences. So, I mean, I'm not the one that's usually doing the rank reviews. It's our data manager, but she's had issues with getting it to run where it just takes too long. Even with just a few, not that many occurrence records.
Yeah, well, there's a few things that could cause things to be slow at any particular point in time. Usually if there's only a few records though, things are pretty quick to run. So that seems unusual, and it'd be worth submitting a ticket if you have less than 100 occurrences, especially, and it's taking a long time. That seems suspicious. Like that something else is happening, and maybe there's an outage of some sort that we don't have control over. But yeah, if you have thousands of records, it can take some time to process the data.
It should be pretty instantaneous for a few hundred records, so that's definitely a surprise. But we've also been working quite actively on the tool over the past months, and I worked through different versions, so it's possible that trying it again now might work a lot better than some time ago.
Jessica?
Yeah, I just, since we're talking about the rank calculator, I just wanted to ask whether there was any movement on the threats analysis and the glitch whereby it will downrank sort of almost randomly if you assign threat.
Yeah, there was recently brought up that we need to reestablish the earwig group and get that conversation going again, as well as
What?
other considerations of methodology changes. But it's there at the moment there we haven't started working on that.
Okay, I mean,
Particular.
I've been raising it for probably about 10 years now.
Yeah. Yeah. Yeah, it's something that we'll be looking at and moving into the coming years. I think there's some rethinking around how to work towards some of the ranking needs. So thank you for bringing it up again.
All right, well, let me know if there's any opportunities to plug in. We just basically don't use threats at this point. We'll do the analysis because the table is nice but we won't factor it into the calculation because it's broken. So
Yeah.
I'll do that part manually. But this looks like a cool tool. Sorry, just had to bring that up because it's a long-standing
okay.
source of frustration. But
For sure.
thanks for sharing about this tool.
Yep. Okay, so we have just a couple minutes left. As a reminder, if you have questions after this meeting, you can check out the forum, you can email the RARECAT support email address, or reach out to us directly if you would prefer. So I think if there are no other questions, we'll go ahead and end for today. We really appreciate your time and feedback and hope you find the tool very useful.